Space is not empty. It only appears that way to those who look quickly. Between the stars lies a vast, ancient silence, stretched across distances so immense that light itself takes years, centuries, even millennia to cross them. In this darkness, there is no sound, no wind, no motion that the human senses could recognize. Yet within this silence, everything begins. How does a star come into existence? Long before a star shines, before it warms planets or lights the sky of distant worlds, it exists only as a possibility, a quiet suggestion hidden inside colossal clouds of gas and dust drifting through galaxies. These clouds, known as nebulae, are the cradles of creation. They are vast beyond comprehension, stretching across light years, composed primarily of hydrogen and helium, elements born in the earliest moments of the universe itself. At first glance, a nebula seems peaceful, ethereal, almost still. But this calm is an illusion. Inside these clouds, gravity is always at work. Gravity does not announce itself. It does not rush. It waits. Over millions of years, tiny variations in density appear within the nebula. A region becomes just slightly thicker than its surroundings, just slightly heavier, and that is enough. Gravity begins to pull matter inward, slowly at first, drawing gas and dust together in an almost imperceptible dance. As more material gathers, the pull strengthens. The cloud collapses inward, not violently, but inevitably. This is the beginning of a star's life. As the cloud contracts, it heats up. Energy builds as particles collide more frequently, squeezed closer together by gravity's relentless grip. The center of this collapsing region grows denser and hotter, forming what astronomers call a protostar, a stellar embryo still hidden within its dusty cocoon. At this stage, the protostar does not yet shine like a true star. It glows faintly from heat alone, warmed by the energy of its own collapse. Surrounding it, a swirling disk of gas and dust spins slowly, material that may one day form planets, moons, asteroids, or comets. The architecture of entire solar systems is quietly taking shape. Time passes on a scale the human mind struggles to grasp. Hundreds of thousands of years, millions. Gravity continues its work, compressing the protostar further. The temperature in its core rises steadily, climbing into the millions of degrees. Pressure becomes almost unimaginable. Atoms are squeezed so tightly that their internal structures begin to change. And then, at a critical threshold, something extraordinary happens. Hydrogen nuclei, protons, are forced so close together that they overcome their natural repulsion. They collide, fuse, and merge into helium. In this moment, nuclear fusion ignites. A star is born. This is not fire as we know it. No oxygen burns, no flame flickers. Instead, the star is powered by the fundamental forces of nature itself. Matter is transformed into energy, following the rules described by Einstein's famous equation. A tiny amount of mass is converted into an enormous release of energy, flooding outward from the core. For the first time, the newborn star pushes back. Radiation pressure surges outward, countering the inward pull of gravity. A delicate balance is achieved. Gravity tries to collapse the star. Fusion energy pushes it outward. This equilibrium, this cosmic tension, defines the star's existence for millions or billions of years to come. The star now truly shines. Its light begins a journey across space, escaping the dense core, passing through layers of plasma, and finally streaming outward into the galaxy. Some of that light may one day reach distant planets. Some may reach living eyes. Some may travel forever, never intercepted. But even at birth, the fate of the star is already written. The most important factor in a star's life is not its location, or its composition, or its surroundings. It is its mass. How much material the star gathered during its formation determines everything that will follow. Small stars, with modest mass, are conservative. They burn their fuel slowly, patiently, sipping hydrogen over trillions of years. These stars live long, stable lives, shining gently and steadily, barely changing over spans of time longer than the age of the universe itself. Larger stars are different. Massive stars are extravagant. They burn hot and fast, consuming their fuel at a furious rate. Their cores reach higher temperatures, enabling fusion reactions that smaller stars will never achieve. They blaze with intense brightness, their surfaces glowing blue or white, radiating immense energy into space. But brilliance comes at a cost. Inside every star, the clock is ticking. As hydrogen fuel is gradually consumed, the balance that defines the star begins to shift. The core changes composition. Helium accumulates, pressure drops. Gravity, patient as ever, begins to regain the upper hand. And what follows is one of the most violent events in the universe. In the heart of the star, everything happens faster than thought. For millions of years, gravity and fusion held each other in perfect tension. Now, in a matter of seconds, that balance shatters. With no energy left to resist it, gravity wins completely. The core collapses. It does not fall slowly. It does not hesitate. The iron core implodes at a significant fraction of the speed of light, crushing atoms together with unimaginable force. Electrons are driven into protons, forming neutrons in a catastrophic squeeze of matter. The star's heart becomes impossibly dense, so dense that a single teaspoon would outweigh a mountain. In this brief, terrifying moment, the core becomes something new. The collapse halts abruptly when nuclear forces push back. Matter rebounds. A shockwave is born at the center of the star and begins to race outward. As it tears through the surrounding layers, temperatures rise to billions of degrees. Neutrinos, ghostly particles that rarely interact with anything, flood outward in unimaginable numbers, carrying away enormous amounts of energy. Then the star explodes. A supernova erupts with a brilliance that can outshine an entire galaxy. For a short time, this single dying star radiates more energy than billions of suns combined. Its outer layers are blasted into space at thousands of kilometers per second, ripping apart the stellar body that once seemed eternal. This is not destruction alone. This is transformation. Inside the supernova's blinding fury, conditions become extreme enough to forge elements heavier than iron. Gold, silver, uranium. The atoms that could never be created during a star's quiet life are born in this final, violent breath. These newly formed elements are hurled into space, seeding the galaxy with the raw materials for future worlds. Every supernova reshapes its surroundings. Shockwaves compress nearby gas clouds, triggering new generations of star formation. Stellar death becomes the spark for stellar birth. The universe recycles itself through fire and collapse, loss and renewal. But the story does not end with the explosion. At the center of the supernova, something remains. If the original star was massive, but not too massive, its crushed core survives as a neutron star. This object is small, barely the size of a city, yet contains more mass than the sun itself. Its gravity is overwhelming. Its surface is smooth beyond imagination, a crystalline lattice of neutrons packed together so tightly that matter itself seems to resist further compression. Neutron stars rotate at astonishing speeds, some spinning hundreds of times per second. As they spin, they sweep beams of radiation across space like cosmic lighthouses. To distant observers, these appear as pulsars, precise, rhythmic signals ticking across the galaxy with almost eerie regularity. These remnants are monuments to extreme physics. They bend space and time. They warp magnetic fields. They remind the universe that even in death, stars do not go quietly. But if the star was truly enormous, if its mass exceeded all limits, then even a neutron star cannot survive. Gravity continues its collapse, crushing matter beyond all known states. The core falls inward endlessly, disappearing behind an invisible boundary known as the event horizon. A black hole is born. Here, space and time are distorted beyond recognition. Not even light can escape. From the outside, the black hole appears calm, silent, almost empty. Yet it holds the memory of a star's entire life compressed into a region smaller than an atom. Black holes are not cosmic monsters roaming the universe in search of destruction. They are consequences, endpoints. The final outcome of nature following its own laws without compromise. Around them, matter may swirl in brilliant disks, heating and glowing as it falls inward. Jets of energy can erupt from their poles, stretching across thousands of light years. Even in darkness, black holes shape galaxies. Not all stars, however, die in such violence. Stars like the sun follow a quieter path. After swelling into red giants, they shed their outer layers gently, creating glowing planetary nebula, delicate shells of gas drifting into space like fading breath. At their centers, the cores remain as white dwarfs, hot, dense embers left behind after fusion ends. White dwarfs no longer generate energy. They simply cool over time, radiating away the heat of their former lives. Over trillions of years, they fade slowly into darkness, becoming black dwarfs, objects the universe has not yet lived long enough to fully produce. Yet even these quiet deaths contribute to the cosmic cycle. Their expelled material enriches interstellar space, adding to the clouds that will one day form new stars, new planets, new possibilities. Across the universe, this cycle repeats endlessly. Stars are born from clouds, they shine through balance, they die through collapse, and in dying, they give the universe more than they ever took. The calcium in bones, the iron in blood, the carbon in cells, all were forged in stellar cores or supernova fires. Life does not merely observe the stars, it is made from them. Every atom heavier than hydrogen carries the history of a star that lived and died long before Earth existed. Ancient civilizations sensed this connection without understanding it. They saw stars as gods, as spirits, as eternal fires pinned to the heavens. They feared sudden new stars appearing in the sky, interpreting supernovae as omens of change or catastrophe. Modern science stripped away the myths, but not the wonder. Today, stars are understood as engines of physics governed by equations and forces. Yet this understanding only deepens their meaning. Knowing how stars live and die does not make them smaller. It makes them more profound. They are not static lights. They are processes. They are stories written in hydrogen and gravity. Every night, sky is a snapshot of stellar lives at different stages. Some stars are newborns, just igniting their cores. Others are ancient elders, nearing their final transformations. Some no longer exist at all, their light still traveling toward us long after their deaths. The universe remembers its stars through light, and through matter, and through us. The universe never truly ends anything, it only changes form. Long after the last light of a supernova fades, long after the final warmth of a white dwarf drifts into the cold background of space. The story continues, quietly, patiently, on timescales far beyond human imagination. The debris of dead stars drifts through galaxies, invisible at first, spread thin across interstellar darkness. Atoms wander alone, separated by vast distances, carrying within them the memory of ancient fires. This scattered matter is not lost. Over millions of years, gravity begins its work once more. Shock waves from distant explosions ripple through space. Galactic arms rotate slowly, stirring clouds of gas and dust. Regions grow denser, temperature rises, motion returns to the silence. From the ashes of stellar death, new nebulae are born. And within them, the cycle prepares to begin again. This is the universe's great rhythm: creation and collapse, ignition and extinguishing, birth and transformation. Stars are not permanent structures carved into the cosmos. They are temporary arrangements of matter, shaped by forces older than time itself. Their lives are long by human standards, but fleeting when measured against the age of the universe. Even the most massive stars, those that burn the brightest and die the most violently, exist only for a moment in cosmic time. Their brilliance is intense, their deaths spectacular, yet their purpose is brief. Smaller stars endure far longer, glowing steadily for trillions of years, quietly shaping the environments around them. Together, they form the architecture of galaxies. Spiral arms glow with young blue stars. Ancient stellar populations cluster in galactic cores. Supernova remnants paint delicate, expanding filaments across space. Every galaxy is a tapestry woven from stellar lives at every stage of existence. In this vast system, nothing is wasted. Matter is recycled endlessly. Hydrogen becomes helium, helium becomes carbon. Carbon becomes oxygen, silicon, iron. When fusion can go no further, gravity takes over, and the elements are scattered back into the universe, ready to be used again. Planets form from stellar remnants. Oceans arise from ancient hydrogen. Atmospheres are built from gases once locked inside stars. Life itself is an echo of stellar death. The atoms that think, feel, and remember were forged in cores that collapsed long before Earth was born. The energy that powers metabolism traces its origin to nuclear fusion. Even the stability of planetary orbits, the warmth of habitable zones, and the chemistry of biology depend on the long, balanced lives of stars. Understanding this changes perspective. Stars are no longer distant decorations in the night sky. They are ancestors, architects, engines of possibility. Their lives shape the structure of the universe and define the conditions under which anything can exist at all. Ancient humans sensed this connection instinctively. They traced constellations across the sky, telling stories of heroes and gods, believing the stars to be eternal watchers above the world. They measured time by their motion, navigated oceans by their positions, and marked the seasons by their rise and fall. Modern science revealed a deeper truth. The stars are not eternal, they are mortal, and in their mortality lies their greatest significance. A universe filled only with unchanging stars would be sterile. Without stellar death, there would be no heavy elements, no rocky planets, no chemistry complex enough for life. Creation requires destruction. Stability requires collapse. The universe advances not by preserving its structures, but by breaking them down and building anew. Even black holes, the most extreme remnants of stellar death, play their role. They sculpt galaxies through gravity. They regulate star formation. They bind cosmic structures together across immense distances. Far from being endings, they are anchors of order in an expanding universe. Time continues to move forward. Billions of years from now, star formation will slow as galaxies exhaust their supply of cold gas. The brightest stars will fade first. Then the smaller ones. The night sky will grow darker, quieter, older. Eventually, only long-lived red dwarfs and the faint glow of cooling remnants will remain. Yet even this distant future is not truly empty. Particles will persist. Energy will remain. The universe will carry the memory of everything that came before. And in ways not yet understood, new processes may emerge, new structures may form, new stories may begin. All of it traces back to the simple act of a star igniting in darkness. So how are stars born, and how do they die? They are born when gravity gathers the universe's most basic elements and lights a fire at the heart of matter itself. They live in balance, shining steadily as long as fusion holds gravity at bay. And they die when that balance breaks, sometimes gently, sometimes violently, returning their substance to the cosmos. Death in the universe is not an ending. It is a transformation. Every star that has ever existed is part of an unbroken chain stretching from the first moments after the Big Bang to the present day. Every atom in existence has passed through multiple forms, multiple stars, multiple epochs. The universe remembers itself through these cycles. In this way, stars are not just objects in space. They are the universe learning how to create complexity. They are the reason there is structure instead of chaos, chemistry instead of simplicity, life instead of emptiness. They are both fleeting and essential, temporary and foundational. And when we look up at the night sky, we are not merely observing distant lights. We are witnessing the ongoing story of creation and collapse, written across space and time in glowing points of ancient fire. The stars shine. They fade. And from their fading, everything else becomes possible. And in that endless cycle, the universe continues, silent, vast, and profoundly alive. In the deepest sense, the universe is a patient storyteller. It does not rush its conclusions. It does not offer clean endings. Instead, it allows its stories to stretch across billions of years, unfolding slowly, layer by layer, like light traveling across interstellar space. What appears to be an ending from one perspective is, from another, only a pause, a quiet turning of the page. Stars embody this truth more clearly than anything else in the cosmos. They begin as whispers in darkness, as faint overdensities in cold, drifting clouds. Gravity gathers them, pressure awakens them, and nuclear fire gives them voice. For millions or billions of years, they speak through light, shaping the worlds around them, defining the architecture of galaxies, and setting the stage for everything that follows. Yet even in their brightest moments, stars are temporary. No matter how massive or how small, every star carries the certainty of change within its core. Fusion alters composition, balance shifts, gravity waits, time, indifferent and unstoppable, moves forward. And eventually, without exception, the conditions that once sustained the star give way to something new. This inevitability does not diminish their beauty, it deepens it. Because the purpose of a star is not permanence. Its purpose is participation in a cycle far larger than itself. A cycle that transforms simplicity into complexity, emptiness into structure, silence into possibility. When a star dies, it does not vanish. It disperses. It spreads its essence across space, enriching the cosmos with the materials needed for future creation. The oxygen in atmospheres, the silicon in rocks, the iron in planetary cores, all of it carries a stellar origin. Every solid world is a monument to long-dead suns. In this sense, the universe is not a place where things simply exist. It is a place where things become. The death of stars is often imagined as violent, catastrophic, final. And sometimes it is. Supernovae tear stars apart with unimaginable force, briefly outshining entire galaxies. Black holes mark regions where gravity has overwhelmed all resistance, drawing matter into darkness beyond return. Yet even these extremes are not failures of nature. They are expressions of it. A supernova is not chaos. It is order operating at its limits. A black hole is not a void. It is structure compressed to its ultimate form. In both cases, the universe is exploring the full range of what its laws allow, and through this exploration, it creates the conditions for novelty. Planets form only because stars die. Life emerges only because earlier generations of stars altered the chemical makeup of the universe. Consciousness itself depends on elements that cannot exist without stellar fusion and stellar collapse. To understand stars, then, is to understand the universe's method of self-transformation. It is also to confront humanity's place within that process. For most of human history, stars were symbols, fixed points in an otherwise changing world. They represented permanence, destiny, guidance. They were believed to be untouched by time, immune to decay. Modern astronomy shattered that illusion, revealing a cosmos in constant motion, where even the largest structures are temporary. But this revelation did not make the universe colder or more mechanical. It made it more intimate. Because if stars are born and die, then they share something fundamental with everything else that exists. Change is not a flaw in the universe. It is its defining feature. Life mirrors this stellar rhythm: birth, growth, transformation, and return. Matter flows through different forms, never static, never wasted. The same atoms that once burned in stellar cores now participate in living systems, in thought, in memory, in awareness. The universe does not stand apart from life. It expresses itself through it. In the far future, long after the last star has faded from the sky, the universe will still carry the imprint of all that has occurred. Radiation will drift through space. Particles will persist. Time will continue. The story will not end, even if its chapters become quieter. And somewhere in that immense future, the echo of stars will remain, encoded in the structure of matter itself. So when we ask how stars are born and how they die, we are not just asking about astrophysics. We are asking how existence sustains itself, how complexity emerges from simplicity, how destruction becomes creation without intention or design. Stars are the universe's way of turning energy into meaning. They transform raw material into structure, time into history, and light into connection. They remind us that nothing truly stands alone and nothing truly ends. Everything participates in something larger, something ongoing. The universe is not built from permanence, but from change. Not from stability, but from balance. Not from isolated objects, but from relationships between gravity and energy, matter and light, birth and death. Stars are where those relationships become visible. They shine, they collapse, they scatter their substance, and from that scattering, new stars are born. Again and again, across galaxies, across epochs, across a universe that is never finished. In the end, stars teach a simple lesson written on the largest possible scale. Nothing in the cosmos exists only for itself. Everything gives rise to something else. And in that endless exchange, the universe continues to create, not toward a final goal, but because creation itself is what it does.